Good morning, all of you. Today we are going to discuss about CPU scheduling algorithms. As we know that CPU scheduling, we are going to discuss about that basic concepts of CPU scheduling. What are the CPU scheduling criterias? Different kind of CPU scheduling algorithms. And further, we'll discuss about thread scheduling and all. As before starting that CPU scheduling, we should know about the objective of CPU scheduling. So our main objective is to maximize the CPU utilization. Okay, as we have different kind of processes. So to implement the multi-programming concept, we need that CPU scheduling. We have the various kind of CPU scheduling. So the description to describe various CPU scheduling algorithm, we need to understand this chapter. To discuss evaluation criteria for selecting a CPU scheduling algorithm for a particular system. To examine the scheduling algorithm for several operating systems. As this is the basic concept that to maximize CPU utilization, we can obtain this by implementing the multi-programming concept. Okay. If we talk about single programmed operating system, then only one program may implement. Now these days the systems are of multi-user, multi-programmed, multitasking, multi-threading operating systems. So that to implement the concept of multi-programming, we have to kind of burst, that CPU IO burst and CPU burst. Okay, that CPU burst cycle means that when the process have assigned on the processor, and IO means that process is waiting for that particular input output operations. So if we have multiple programs, and one process may execute on CPU and another may wait. When another process is waiting for IO operations, then the third process can execute. So this is the benefit in multi-programming. So this is the histogram of CPU burst times. The x-axis represent the burst duration, and the y-axis represent the frequency. So we can say that we have the processes with short duration. The process with that long burst durations are less in number. There are different kind of CPU schedulers, that short-term scheduler, that long-term scheduler, and medium-term scheduler. Normally, that CPU scheduler is the meaning of that short-term only. That by default, that we are talking about CPU scheduler, and that is the short-term scheduler. The job role of short-term scheduler is to select processes from the ready queue and allocate the CPU to one of them. That queue may be ordered in various ways. So CPU scheduling decision may take place when a process switching from running. In the previous lectures, we have discussed about different kind of states of the process. That process may be in running state, waiting state, or ready state. So that switching from waiting to ready is the job role of that CPU scheduling, running to ready state or running to waiting state. Or if process moves in terminate state, then also. So there are two kind of algorithms, that non-preemptive scheduling algorithms and preemptive scheduling algorithm. In preemptive scheduling algorithm, that we can forcefully preempt the process or take the resources from the particular process. Non-preemptive means once the processor is allocated to particular process, until and unless the execution of that particular process will not be over, we can't take the resources from the process. So that is about non-preemptive scheduling. Dispatcher just dispatch the jobs, okay, to the particular processes. There are different CPU criteria. Somewhere you will find that what are the goals of CPU scheduling. Somewhere you will find that scheduling criterias or the performance parameters of CPU scheduling. As we have different kind of algorithms, so I will judge that this algorithm is better than another. So for that we have CPU utilization, throughput, turnaround time, waiting time, and response time. These are the parameters for CPU scheduling. Okay, so CPU utilization, we want that our target is that no processor should be idle. So we want that CPU utilization should be 100%. Throughput, definitely throughput to be high. That number of processes are executed in per unit time. So that we want more and more. Turnaround time, we want to minimize the turnaround time. As turnaround time, we can define that waiting time plus response time is called waiting time plus execution time is called turnaround time. Okay, waiting time means the time at for which the process has been wait in the ready queue. Okay, waiting for the resource or waiting for the processor to execute. And execution time, that burst time is associated that this much time that particular process will take. So turnaround time means total time taken by the process. So process may be either in waiting state or in the execution state. So turnaround time is defined as waiting time plus execution time. Response time, as we know that we want that response time to be minimum, or that fast response to be taken care by, but always will count that first response is given by the process whenever we have submitted the request and when we'll get the response. So what criteria is associated, that we want maximum CPU utilization, maximum throughput, minimum turnaround time, minimum waiting time, and minimum response time. Somewhere you will find context switches also. As context, if we have more number of context switches in the system, then the overhead will be increased. So we also want to minimize the context switches. As different kind of scheduling algorithms are there. First come first serve scheduling algorithm, shortest job first scheduling algorithm, and the priority scheduling algorithm, round robin scheduling algorithm, multi queue scheduling algorithm, multi queue feedback queue scheduling algorithm, fair share scheduling algorithms. But today we'll discuss about first come first serve CPU scheduling algorithm. What is given in this slide, that process names are given. As we have assumed here, three processes are there. Their execution time is given 24, 3 and 3 units. So the arrival of the process or the order of arrival is given as P1, P2 and P3. The P1 process arrives first, P2 and P3 then. So as the name suggests, this algorithm executes on first come first basis. So first the arrival of that process is P1, then P2 and then P3. So you can see the execution time of P1 is 24 unit. So at time instant 0, we have allocated the processor to the process P1. So P1's execution time is 24, so it has executed. At 24, the next arrived process or the sequence is of P2. So we have allocated the processor to P2 and then we have allocated to P3. So P1, P2, P3 in sequence we have executed. So total you can calculate the bus times, total 24 plus 3 plus 3 is 30, and here also that answer is 30. So means your question is right, or you have do the addition on right manner. So how we calculate this chart is called Gantt chart. Okay, sometimes you will find in the question that draw the Gantt chart. So this is Gantt chart. So waiting time for P1, how we can calculate? We can see what we have assumed, that here no arrival time is given in the question. So the assumption is we assume that all process arrived at time instant 0. So at 0 we have allocated P1 0 pay 0 at 0 that process has come and we have allocated at 0 itself. So there is no waiting time for P1. For P2 we can check that as the process has arrived at 0 itself, but at 24 unit that process has wait. So for P2 the waiting time is 24, and from the diagram itself we can say that for P3 27 units, as the all process arrives at same time unit. Okay, so we can calculate the average also, because always we are talking about average result. We will not talk that P1 is very good, that P1's waiting time is 0. No, we always talk about that average waiting time. So we have calculated the average waiting time here, that is 17 units, and that is a huge number. 17 is a huge number. Suppose we'll reverse the order of the process, or arrival order of the process. What we have reversed, that instead that P2 come first, then P3 and then P1. and their burst time we know 3, 3 and 24. So you can see that the Gantt chart will be drawn in this manner. P2 will the sequence P2, then P3 and then P1. Now you can check the waiting time of P1 is 6 time units. Okay, P1, as all process has arrived at 0, so P1's waiting time is 6 and P2 is 0, and for P3 it's 3 time unit. So if we'll calculate the average of this, then that is 3 only. You have seen in P1, P2, P3 order the time was 17, and when you change the order, then it's 3. This is much better than the previous case. Okay, so here is you can see the drastic difference in the average waiting time. So FCFS is very simple to implement, but the drawback is the we can say that waiting time or turnaround time is huge in FCFS and depend on the data. Here you can have one look on one effect also, that is called conveyor effect. When the short processes are executed, the long process behind long processes, then the drastic change is there. Then this effect sometimes called conveyor effect. Consider one CPU bound and many IO bound processes. So at that case, the data will be changed in FCFS. So next, in next lecture, we'll discuss about the shortest job first algorithm. Okay, so this is about that first come first serve CPU scheduling algorithm. I hope this is clear to you all. Okay, if you have any doubt, then you can leave in the query, okay, or chat box. Thank you all.